Alright, so in this example problem we're going to apply Gauss's law. So we have a diagram here where we have our origin here, and charge 2 is 2.5 meters in the y direction, and charge 1 is 0.5 meters in the x direction. And we want to know when r equals 0.3, when r equals 2 meters, and when r equals 3 meters, we want to know what the electric flux is. So when r equals 0.3 meters, remember our electric flux equals the E dot A, or it equals Q enclosed divided by the electric constant. So since we're not given the electric field strength or the area directly, we'd have to go through and calculate them. It's easier to use the idea that the electric flux is equal to Q enclosed over the electric constant, because we know what the charge is. So we just have to determine how much charge is enclosed in each of the circles. So when r equals 0.3 meters, let's see, this is 0.5 away, this is 2.5 away, so our circle would be like in here. There's no charge enclosed, so the electric flux is going to be 0. For our second radius, so 2 meters, 2 meters is greater than 0.5, so Q1 would be enclosed, but it's less than 2.5, so Q2 would not be enclosed. So that means only charge 1 is enclosed, and charge 1 has a value of 3 microcoulombs, so 3 times 10 to the minus 6 coulombs. And I'm going to divide that by the electric constant, which gives me an electric flux of 3.39 times 10 to the 5 Newton meters squared per coulomb. And then for our last scenario, we're looking at r equals 3 meters, so that means both charge 2 and charge 1 are going to be enclosed. So let's see, that's 3 microcoulombs and 6 microcoulombs, so you add them together, you get 9 microcoulombs, so 9 times 10 to the minus 6 divided by the electric constant, and it gives us an electric flux of 1.02 times 10 to the 6 Newton meters squared per coulombs. So don't forget, there are two definitions for electric flux now. One that says the electric flux is equal to electric field dotted with the area, and the other is the idea that the electric flux is equal to the charge enclosed divided by the electric constant.